We were brazenly lied to right in our faces during every history lesson, and we meekly nodded along, accepting the absurd as truth. Have you ever wondered what this gigantic monster connecting Manhattan and Brooklyn is really standing on? Official science calmly declares to us that the Brooklyn Bridge, this colossal structure of granite and steel weighing tens of thousands of tons, rests on wooden boxes. You didn't mishear, on wood. They're trying to convince us that at the end of the 19th century, when people didn't even have proper scuba gear yet, when electricity was a novelty and medicine treated illnesses with bloodletting, the builders managed to lower giant wooden boxes called caissons to the bottom of the turbulent East River and build stone mountains on them. It sounds like a bad joke, but that's exactly what's written in every encyclopedia. However, just switch on critical thinking for a second and cast aside school dogmas, and this entire neat theory crumbles to dust, revealing the frightening truth about our past. Let's look at the facts that should make any engineer's hair stand on end. We're told construction began in 1870. Chief Engineer John Roebling dies even before work starts from a ridiculous foot injury. His son, Washington Roebling, picks up the banner and begins sinking those very wooden caissons. What is a caisson? Essentially, it's an upside-down wooden box the size of half a football field. Imagine a structure of yellow pine, nailed and bolted together, sunk into icy water. Inside this box are people. They dig the riverbed with shovels in the dim light of gas lamps, in stale air, under monstrous water pressure that could squash them flat at any moment. And now they start stacking granite blocks on the roof of this wooden raft, one after another. Thousands of tons of stone. The official version states that under the weight of the granite tower, the wooden box settled into the silt, and the workers inside shoveled out the ground from under it until the caisson reached solid bedrock. But here's where it gets really interesting. Did you know that under the Brooklyn Tower, the caisson never reached bedrock? It stopped on a layer of sand. The engineers simply decided that would do, because the sand was supposedly dense enough. Think about this nonsense. A tower weighing 90,000 tons stands on a wooden cushion that's been hanging in a layer of sand underwater for a century and a half. Wood. In water. Under the pressure of 90,000 tons. Anyone who's ever seen what happens to wood in water over a couple of decades will tell you that it rots, softens, or turns to mush. But we're told that the pine under the Brooklyn Bridge is special. It's supposedly been preserved. Now let's talk about the numbers and logistics that historians so dislike discussing. The size of the Brooklyn side caisson was 168 by 100 feet. That's a huge area. To lower such a monster evenly, without tilts, onto the uneven riverbed with boulders and rocky outcrops, you need jeweler's precision and 21st century hydraulic equipment. They only had hand winches and steam engines. How did they level this behemoth blindly under murky water? The slightest tilt of a couple of inches at the bottom would give a deviation of yards at the top. The tower would simply collapse under its own weight during construction. But it stands perfectly straight, as if it grew out of the water or was always there. Maybe because no one built it in the 19th century? Maybe these wooden boxes weren't needed for building the foundation at all, but for something else? For example, for clearing and exploring an already existing ancient base left from a previous, more advanced civilization? Look at the old engravings and construction photos. They look strange, don't they? We see already completed, massive granite towers rising above the water, and people scurrying around them on some flimsy wooden scaffolding. This picture resembles ants crawling over a dinosaur skeleton. The contrast between the primitiveness of the technology of that time and the grandeur of the structure itself simply cuts the eye. The granite masonry of the towers is done with such precision that you can't slip a knife blade between the blocks. This is megalithic masonry, characteristic of ancient structures or buildings that we habitually attribute to the Romans or Egyptians. Where did yesterday's immigrants, working for pennies, get the skills for high-precision processing of the hardest granite? Where are the quarries capable of producing such volumes of perfect blocks on an industrial scale without diamond saws and CNC machines? We're told it was all done by hand, with chisel and hammer. Millions of blows, hundreds of thousands of man-hours of perfect, error-free work. Do you believe this? There's one more terrifying detail that historians write off as inevitable losses: caisson disease. This is the condition when nitrogen in the blood boils due to a sudden pressure change upon rising from depth. Hundreds of workers became disabled. Dozens died in terrible agony. The chief engineer himself, Washington Roebling, was paralyzed and supposedly oversaw the construction from the window of his apartment, observing the process through a spyglass. What a convenient legend. The main witness and technical brain of the project is sidelined and silenced forever. His wife, Emily Roebling, suddenly becomes the intermediary and effectively leads the completion of the construction. A woman in a corset in the 19th century manages the world's most complex engineering project, passing notes from her half-mad husband? Seriously? Or maybe Washington Roebling saw something down there, at the bottom, in that cursed caisson that his mind couldn't withstand. What if caisson disease was just a cover for something more sinister? What if they stumbled upon technologies they couldn't explain, or entrances to underground communications that we're forbidden to know about? Imagine an alternative scenario. The bridge had stood there for hundreds, or maybe thousands of years. It was the legacy of that very unified world architecture, traces of which we find from St. Petersburg to San Francisco. Majestic arched spans, granite supports plunging deep into the Earth's bowels. But a catastrophe occurred. A global flood or war that wiped civilization from the face of the Earth. The water level rose, the bridge was partially destroyed, cables snapped, spans collapsed. An era of oblivion ensued. And then, in the mid-19th century, the new masters of life, who had seized the empty cities, decide to restore the transportation artery. They don't build the supports from scratch. They excavate them. The caissons weren't needed to pour concrete, but to seal the space around the ancient supports, pump out the water, and restore the old stone that extended deep into the silt. The workers died not from construction, but from attempts to penetrate ancient flooded levels, where traps or unknown bacteria and gases awaited them. Let's return to the numbers, because mathematics is the only language on which it's impossible to lie if you know how to read the equations correctly. The weight of one tower is about 90,000 tons. The base area on the New York side is 174 by 102 feet. This gives us a soil pressure of roughly 78 pounds per square inch. That's colossal pressure. And this pressure is transmitted through a wooden raft just a few feet thick. Wood is an anisotropic material. It has fibers. Under such a load, and in the aggressive environment of saltwater, the wood structure should have irreversibly deformed within the first 10 years. 140 years have passed. The bridge hasn't settled an inch. No cracks in the granite masonry, which would inevitably appear at the slightest movement of the foundation. This is physically impossible if the foundation is truly wooden. This contradicts the laws of strength of materials. Either there's wood down there underwater, infused with elven magic, or there's no wood at all. There it's granite on granite. Or, even more likely, the supports are a monolithic extension of the bedrock foundation, carved out by a technology of plasma stone cutting unknown to us. Historians claim that the caissons were filled with concrete after reaching the required depth, but the composition of that concrete raises a ton of questions. Back then, cement was nowhere near the quality it is today. It set slowly, was porous and brittle, pouring thousands of cubic yards of concrete into a caisson under pressure, ensuring the structure's solidity without air pockets or delaminations. That's a task that's barely feasible even today. And back then, they supposedly mixed the mortar with shovels and lowered it in buckets through airlocks. If there really were voids or subpar concrete down there, the water pressure would have eroded the base long ago, and we'd have seen the Brooklyn Colossus fall at the start of the 20th century. But it stands. It has survived hurricanes, a hundreds-fold increase in traffic load, vibrations from subways and cars. This tells us only one thing. The safety margin of this structure wasn't calculated for horse-drawn carriages. It was built to withstand loads that people of the 19th century couldn't even imagine. Or else it was built by those who knew far more about technologies than we do. We look at black and white photos of bearded guys in hats posing in front of the bridge under construction, and we think, there they are, the heroes. But take a closer look at their faces. Do you see the pride of creators there? Or do you see fear and bewilderment? They don't look like design engineers, but like scavengers trying to repurpose for their own needs what they found among the ruins. They're stringing thin steel cables onto gigantic stone pylons that were clearly made for something far more grandiose. The cables themselves are a whole other story, which we'll get to shortly. But right now, it's important to hammer home one thought. The Brooklyn Bridge Foundation is a fiction. It's a smokescreen behind which hides the truth about antediluvian technologies. The wooden caisson is a fairy tale for children, so they don't ask extra questions about how you can build eternity on rotten boards. And if we admit that the foundation isn't what they claim it is, we'll have to rethink the entire history of American megacity construction. And believe me, that's very dangerous for those who write the school textbooks. Lift your heads up. Tear your gaze away from the spot where, according to official fairy tales, wooden boxes are rotting, and look at this gigantic steel web holding thousands of tons of roadway in the air. Steel cables. This is the second, and perhaps the most brazen miracle of the Brooklyn Bridge that we're forced to believe in without a single piece of evidence. We're told this was the first suspension structure in the world using steel cables. Sounds proud, until you start digging into the details of metallurgy in the second half of the 19th century. Let's recall what steel was like in 1870. It was an expensive, finicky, and extremely difficult to produce material. Before the Bessemer process was invented, which was only just starting to be implemented and was highly unstable, steel was used to make knives, razors, watch springs. It was a jeweler's material, not a construction one. Iron, yes, cast iron, sure, but high-strength alloy steel on an industrial scale for a bridge spanning nearly 1,600 feet. That's like claiming today that we're building a skyscraper entirely out of graphene or iridium. The official legend states that John Roebling invented a revolutionary method of weaving the cables right on site. Supposedly, it was impossible to manufacture a thick rope at the factory and bring it. It would be too heavy. So they decided to pull thin wires, just a few millimeters in diameter, from one shore to the other and back and forth, like a gigantic weaving loom. Imagine the scene. Open river, constant winds, fogs, rains, and snowstorms. And in these conditions, Workers pull wire over a kilometer long, more than 3,000 feet. 5,434 wires in each of the 4 main cables. Think about that number. 21,000 wires. They didn't just need to string them across, they had to lay them with perfectly equal tension. If one wire is tensioned just a bit tighter, it snaps first, transferring the load to the neighbors and causing a chain reaction. In the conditions of the 19th century, without laser rangefinders, strain gauges, and computer load modeling, achieving such even tension in the wind is physically impossible. This is absurd. Either they had eagle vision and pianist finger sensitivity, or this whole story of weaving in the wind is complete fiction. Moving on. The corrosion problem. Steel wire in New York's salty sea fog should have started rusting even before they finished weaving the first cable. We're told about galvanization, zinc coating, but the hot-dip galvanizing technology of that time was primitive. The layer was uneven and porous. Any scratch during installation, and there were thousands, became a rust hotspot. Yet the cables hang. They've been hanging for a century and a half. Modern cable-stayed bridges require cable replacement every 30 to 40 years because the metal fatigues and corrosion eats it from inside. But the Brooklyn Patriarch spits on the laws of chemistry. Its cables, supposedly made by semi-literate workers from experimental steel, have outlived all their modern competitors. Maybe the secret isn't in Roebling's genius, but in the fact that this metal has a completely different composition? Maybe it's that very eternal metal, the secret of which was lost along with Tartaria, and which we today can't reproduce even in the best laboratories. And now about the grandest scandal, which historians shyly call an unfortunate incident. In the midst of construction, it turned out that the wire supplier, a certain gentleman named Haig, was supplying defective steel to the site. The wire was brittle and didn't hold up. Suddenly it turns out that the load-bearing cables, the strand backbone of the entire bridge, are made of rotten, brittle metal that failed the tensile tests. What would any sane engineer do? He'd stop construction, cut out the defect, and start over. That's the only way to guarantee safety. But what do Washington Roebling and his team do? They make a decision that would make any modern strength of materials expert faint. They decide to simply leave the defective wire inside the cable and add 150 additional good wires on top. It's like discovering that your house's foundation is made of styrofoam, and instead of rebuilding it, you just glue another layer of wallpaper on the facade. Adding weight to an already weakened defective core only worsens the problem, increasing the dead load. If this bridge were really held by those very cables they were weaving there, it would have collapsed into the water on the first frosty day, when the metal contracted and the brittle core snapped. But the bridge stands, and that can mean only one thing. Those cables they wove with such fanfare for the cameras, and about which newspapers wrote, don't bear the main load at all. It's props, decoration. Perhaps the real load-bearing structure is hidden somewhere else, where those very old cables left from the previous civilization were so strong that all this fuss with new wire was just a show, for money laundering and creating the illusion of grand construction. Notice the diagonal stays that fan out from the towers to the roadway. Roebling claimed this was a backup system in case the main cables broke. Think about that statement. An engineer builds in a system beforehand that should hold the bridge if the main structure fails? That means he knew the main cables were fake. This redundancy in the design is uncharacteristic of 19th century capitalism, where they saved every penny. It looks more like they didn't understand how the ancient system worked and slapped everything on just in case so it wouldn't fall. Now let's look at the architectural style. Gothic. Pointed arches. Why? The 19th century is the era of steam, cast iron, and functionalism. Factories, train stations, warehouses, all built utilitarian. And suddenly, in the middle of New York, two gigantic stone cathedrals sprout up, jutting from the water. The pointed arch is a complex, expensive element from church architecture. We're told it's for beauty. But in engineering on this scale, beauty is a byproduct of function. Gothic cathedrals, as we know from alternative research, could serve as resonators, atmospheric electricity stations, or sound vibration systems. The two Brooklyn Bridge towers perfectly replicate the shape of portals from ancient temples.
What if these towers aren't just supports for cables? What if they are technical devices, generators, or breakwaters left from an era when technology was inseparable from architecture? The passages through the towers themselves are narrow and inconvenient for traffic. If they were built in the 19th century specifically for the flow of carriages and future cars, they would have made them wide and square. But the builders were forced to fit the road into already existing ancient arches that were clearly not intended for coal trucks. And here we come to one of the darkest episodes in the bridge's history, which happened just a week after its opening. May 30th, 1883. People are strolling on the bridge. Suddenly a woman, climbing the wooden steps, stumbles and falls. A scream rings out, and instantly, as if on command, the crowd is seized by animal, irrational terror. Someone shouts, "The bridge is collapsing!" A stampede begins. People trample each other, fall over the edge, break bones. 12 people died, dozens maimed. The official version is mass hysteria, but ask yourself, why did New York residents, who supposedly watched the construction for 14 years and saw its reliability, so easily believe that the granite colossus was crumbling? Where did this subconscious fear come from? Maybe because on a genetic level, they remembered past catastrophes? Or because rumors that the bridge was ancient junk just painted over circulated through the city far more actively than bombastic newspaper articles? People weren't afraid of the new bridge. They were afraid that the ancient gods were angry again. This tragedy looks like a strange sacrifice needed to activate the object, a bloody seal on a new contract between the authorities and the city. Now look at the logistics of material delivery. We're told the granite was shipped from quarries in Maine on schooners, 90,000 tons per tower. Plus approaches, anchorages, that's millions of tons of stone. Where's the giant fleet that should have been shuttling non-stop? Where are the photos of clogged ports, mountains of unloaded stone? In construction photos, we see just a couple of barges and piles of debris. No sense of an industrial anthill. The streets of New York and Brooklyn at that time were mud and cobblestones. How did they haul multi-ton blocks along them to the site? Wagon wheels would sink hub deep. Roads would be destroyed. But the city lives its normal life. No transport collapses. It creates the impression that the stone wasn't brought in. It was already there. Perhaps they dredged it from the bottom, lifted it from ruins, cleaned it of silt and seaweed. The construction site wasn't an assembly area, but an archaeological excavation and restoration zone. And most importantly, why was it necessary to connect New York and Brooklyn with such a titanic effort exactly then? At that time, Brooklyn was a separate city, quiet and patriarchal. New York was an overpopulated cauldron. Ferry service handled it perfectly. There was no economic necessity to pour $15 million of that time into construction, an astronomical sum equivalent to billions today. Unless the goal was something else. The bridge became a tool of unification. Right after its opening, Brooklyn was absorbed by New York, becoming its borough.
This was an operation to merge territories, to create a megacity of the New World Order. And for that, they needed a symbol of man's power over nature. But the irony is that this symbol they didn't build. They stole it from their ancestors. They appropriated the greatness of the past, passing it off as the progress of the present. And to keep this lie standing, they had to rewrite the engineers' biographies, invent heroic myths about caissons, and turn a blind eye to blatant violations of the laws of physics.
But if you think the strangeness ends there, you're deeply mistaken. Because we haven't even touched on the topic of population yet. Who really built this bridge if half the country still hadn't recovered from the Civil War and the cities stood half empty? Let's step away from granite and steel and look at the most unreliable but most important resource of any construction: people. If we believe the official statistics, the Brooklyn Bridge was built during the period when the United States was just crawling out of the bloody mess of the Civil War. The country was torn apart, the Southern economy destroyed, hundreds of thousands of able-bodied men rotting in the ground or returning home as cripples. And suddenly, as if by a wave of a magic wand, in the 1870s, an unprecedented construction boom begins. Across the country, capitals with ancient domes, train stations like palaces, and giant bridges sprout up like mushrooms after rain. Where did all the hands for this come from? We're told about immigrants. Supposedly millions of Irish, Germans, and Italians flooded into the New World and happily grabbed their picks. But let's be realistic. Most of these people were illiterate peasants fleeing famine. They knew how to plant potatoes and herd sheep. But constructing a Brooklyn Bridge-class structure requires an army of highly qualified specialists. Where did they study? Where are those hundreds of technical schools that should have been turning out thousands of engineers, surveyors, top-tier stonemasons, metallurgists, and steam engine operators? To train a master capable of perfectly dressing a granite block for an arch takes 10 to 15 years of practice under a mentor's supervision. Where is this school of masters? It doesn't exist. There's a gaping hole in the history of American education. It feels like these specialists materialized out of thin air. Or, much more frightening and plausible, there was no construction on the scale they're painting for us. There was only clearing, repair, and adaptation. The city population of that time was physically incapable of creating such infrastructure from scratch. Look at the panoramic shots of late 19th century New York. Endless fields of brick buildings, spires, towers, factories, and empty streets. Sparse wagons, solitary pedestrians. The city looks deserted. This doesn't resemble an anthill buzzing with creative energy. It looks like a set into which a handful of new residents was released. We behave like hermit crabs that found an empty shell of a giant mollusk and settled into it, proudly claiming that we grew it ourselves. The Brooklyn Bridge is excessive for the 19th century. Why build such a monster for horse-drawn carriages? The bridge's width, its load-bearing capacity, the span height, all calculated for traffic flows and loads that simply didn't exist then. Capitalist engineers don't spend money on thin air. They build exactly as much as needed to extract profit here and now. But this bridge is built with a safety margin for millennia, like the pyramids. Moreover, look at the famous wooden pedestrian promenade elevated above the roadway. That's a most complex engineering solution. Why, in the era of wild capitalism, when child labor was the norm and a worker's life wasn't worth a dime, spend colossal sums on a promenade with panoramic views? It doesn't fit the mentality of that era. It looks more like the legacy of a civilization for which comfort and aesthetics were integral parts of technology. A civilization where man was not a resource, but a creator. Notice the approaches to the bridge. These are gigantic brick arcades stretching hundreds of yards inland. Inside these arches today are warehouses, shops, and sometimes just walled-up voids. Historians say these are specially built viaducts.
But if you look closely at the masonry at the base of these arches, you can notice something strange. They go deep underground. What we see as the first floor is often the second or third. The ground level around the bridge is artificially raised, or rather, the buildings are buried under a layer of soil. This brings us back to the theory of a global catastrophe, that very clay flood that covered the cities with mud. The Brooklyn Bridge doesn't just connect the shores, it grows out of these buried layers. Perhaps its spans were much higher above the water before the catastrophe. We see only the tip of the iceberg, the upper part of the ancient world's transportation system that was managed to excavate and put into operation. And one more fact that sends chills down the spine: the anchorages. These are massive stone structures on the shores where the main cables are attached. In size and amount of stone, they can rival Egyptian temples. Inside them are labyrinths of dark halls and vaulted ceilings. Officially, they are empty or used as storage for city property. During the Cold War era, they even equipped bomb shelters there with supplies of water and crackers, which were discovered by chance only in 2006. Think about it. There are secret rooms in the bridge's anchorages that were forgotten for 50 years. What else do these granite mountains hide? Maybe these anchorages aren't just dead weight to hold the cables. Maybe they were former power stations. If we assume that the bridge could transmit energy, recall atmospheric electricity and the metal in the structure, then the anchorages could have served as transformers or accumulators. Their shape, mass, specific masonry, all this resembles technical casings for equipment that was long ago removed or crumbled to dust. We look at the bridge and see a road, but the ancients might have seen something entirely different in it. A tool, a resonator, part of a global network. And we, the new people who came to the ruins, simply strung our thin wires, laid down planks, and sent our primitive, gasoline-fuming cars over this technological wonder. We use a microscope to hammer nails. And the most offensive thing is that we're forbidden even to think that this microscope is a complex instrument. They've convinced us that it's just a very big and heavy hammer that our grandfather made from a log. This lie doesn't just distort the past, it steals our future. Because if we don't understand how it was really built, we'll never be able to replicate this success. We're doomed to endlessly patch asphalt holes and paint rusting railings, wondering why everything we build falls apart in 10 years, while theirs stood for centuries. The demographic pit of the 19th century is a death sentence for official history. There was no one to build these cities, no one to dress millions of tons of granite. Either the Earth's population was many times larger and vanished overnight, or the technologies allowed one operator to do the work of thousands of ditch diggers. In any case, the textbooks lie. And this lie is so global that admitting it would mean collapsing the foundation of modern statehood. Because if it turns out that all our heritage doesn't belong to us, the question arises, who then is the true owner? And will he return for his property? The Brooklyn Bridge stands as a silent witness to the crime of the century, the theft of history from all of humanity. It looks at us with its Gothic eye sockets and waits for us to wake up.